Good morning, friends. Welcome to another video. We're gonna be finding inverse trig functions. Okay, slay. Okay, so a few things to note. I'm gonna draw this we're gonna review. So, how should I do this? We're gonna do a little review. How should I do this? Okay. So, I have made these lines. Basically, we're gonna do a little review. So it's a function. What is happening? Okay, sine theta. Do domain. D range period. Okay, so for sine, opposite of hypotenuse, the domain is all real numbers, and the range is -1 to 1, and the period is 2 pi. For cosine theta, the inverse, the domain is also all real numbers, and the range is -1 to 1, and the period is 2 pi. So same as sine. And then for tan is different. It's all reals except, how do you do except? Is it a line? It might be a dash. Except k pi plus pi over 2. And if you remember from like 2 videos ago, the graph, when you graph trig functions, you use the formula y equals a sine b x minus h plus k. So that's okay. I don't know, I don't really remember that. Like, I don't use it when I graph. Is it pi? Wait. Okay, all real numbers is the range of tan, and then the period is pi. And then let's do the reciprocals. So cosecant, which is all reals except for k pi, which I don't when does that come into use? I don't know. But okay, so union 1 and infinity. Okay, secant is the same as tan. Copy. How do I paste? Wait. How do I paste? Oh, okay. That's too bad. K pi plus pi over 2. And what? The range is the same as cosecant. This is parentheses. Okay. Period is 2 pi. And the cotangent, all real, is the same as cosecant. For cotangent is the same as cosecant. So all reals except k pi. All reals for range. This is range, right? Yeah. And the period is pi. And then we know that acronym, all students take calc. And so these functions are all positive in quadrant 1. Only sine is positive in quadrant 2. Only tan is positive in quadrant 3. And only cosine is positive in quadrant 4. And the same applies for their reciprocals. Yeah. Okay. So let's do, so this is like the table for domain, ranges, and periods of like the regular trig functions, but let's do another one for the inverses. So sine inverse. Okay, so when something says like sine inverse, say sine inverse x, it's the same as arcsine x. Yeah, so I'm just gonna write sine inverse for now. So you have sine inverse, cosine inverse, tan inverse, cosecant inverse, secant and inverse, cotangent inverse. And then let's say domain. Then range. I believe, yeah, okay, so domain of sine inverse is -1 to 1. Range is negative pi over 2 to pi over 2. This is the same. Tan inverse is all reals, and then the range, this is parentheses. Cosecant and secant are the same. It's union 1 to infinity, and secant is negative infinity to -1. Oh, -1 union 1 infinity. Three pi over 2. And this is 0 over pi over 2 union pi comma 3 pi over 2, all reals, and this is pi 0 comma pi. Yeah, so basically these are the inverse functions, and it has like the same, it looks the same as the parent function, or like the OG function, but reflected over the line y equals x. So this line is, hold on. So you have this line y equals x, and basically the inverse say y equals f inverse of x. It has the same shape as the OG function, the original function, but is reflected over the line, the slanted line here, y equals x. Okay, so was that a review? Kind of. So let's do a little bit more review. So we know sine, the graph of sine, y, oh wait, you know what, let's not do that. y equals sine x, right? The graph will look something like arcsine or sine inverse. Y equals sine inverse x looks something like that, but it ends, okay? And then think of, okay, so just like, yeah, that's like the rest of it. But it's not in this, it's not the thing. And then cosine is, so this is y equals cosine x. And it starts at the max, and the period ends at the max, if it's positive. If it's negative, it will start at the min and at the min. Arcsine, or sine, wait, no, not arcsine. Arccosine, or cosine inverse, is going to be like that. So you're just getting rid of whatever it is that, is that half a period? It's basically half a period. And it's a one-to-one function. And this, like the regular graphs, are reflected across that y equals x line, and then you only keep, so this is a dot because it ends there. You only keep that specific section of the thing. Yeah, anyways, y equals tan x is like these things. Oh, okay, it's gonna go past the origin, and it's the one with like a bunch of not intercepts, horizontal asymptotes. Okay, and then you have tan inverse, and it's reflected across as well, but tan doesn't stop. Yeah, it just keeps going. Oh, it just keeps going. Okay. Yeah. Yeah. Okay. What were we doing? Inverse trig function? Oh, okay, so what did I think of? So when you find inverse trig functions, I should have it's fine, I'll just write them. Okay. So let's say, like, if it asks you to find sine inverse of square root of 2 over 2, it's basically asking, wait, hold on. Wait, should I put this in another video? I'll do it, wait. Actually, yeah. I'm gonna put the worksheet part in another video. Actually, no, I'm not. It's fine. Okay, so inverse trig functions. Inverse trig function. The answer is the angle measure. Okay, and trig function is the ratio. BTW. Okay, example. Let's say it's asking us to find tan inverse of square root of 3 over 3. It's basically asking us tan, it's the same thing as saying tan, if I were to rewrite this, it's the same as tan theta square equals square root of 3 over 3. And it's asking tan is positive in Q1, and it's saying, well, it's not saying, but tan is positive in quadrant 1 and quadrant 3, and so you have to find out like which one it is in. So we'll go over that in a second, but basically square root of 3 over 3 is the same as 1 over square root of 3. And we know tan is opposite over adjacent. So that means the opposite had to be 1/2 and the adjacent had to be square root of 3 over 2. Because 1/2 times 2 over square root of 3 would give you this. So that would mean the answer is... What's the answer? Oh, you need to find where it is, what the angle measure is at the point where, on the unit circle, where the opposite is 1/2 and the adjacent is square root of 3 over 2. So I'm going to draw a little circle. Okay, where is it going to be 1/2 and where's the opposite going to be 1/2? Here, right? 1/2 and adjacent is, yeah, so it's going to be here. The angle measure here is 30 degrees, which in radians is pi over 6. So theta is pi over 6. So that's going to be your answer. It can get confusing because it'll seem like there's more than one answer, well, there actually isn't. So something to keep in mind. Sine inverse of x. So earlier we reviewed the ranges and domains. If you were to take your calculator and put in sine inverse of, say, 2, it says something. It says domain error, because sine inverse of 2, or just 2 in the place of x, doesn't exist. So the answer would be does not exist if it was asking for sine inverse of 2, because in the unit circle, like, it only goes to 1, so it doesn't exist. So technically, say the example we just did, right? I said the opposite had to be this, the adjacent had to be this, and that could be more than one point on the circle. It could be here, it could be here, it could be here. But in this case, with this specific ratio, with the specific question that it's asking, it's only limited to quadrant 1 and technically quadrant 2 as well. So, like I was saying, something to keep in mind is, this is based off of the domains and ranges. When it asks you to find that, we'll do example problems after, but when it asks you to find the kind of problems that we're about to do, sine can only be from here to here. So, your angle can be positive up to pi over 2. No, pi over 2. Yeah, pi over 2. Or it can go negative this way, and let me finish drawing this. So these are where your solutions can be. So when I find the solution, I like to draw the circle to visually see that it falls within the domain and the range. So sine, it can go to these two, quadrant 1 and 2. Oh, not 2, 1 and 4. And then quadrant 4, this is quadrant 4. Quadrant 1 and 2, quadrant 1 and 4. Okay, what is it? Okay, so if it's up here, it's positive, it's negative. Positive here, negative here. Positive here, negative here. Something to note is that. So we're going to keep that in mind when we do these problems that we're going to do right now. So, sine inverse of square root of 2 over 2. It's asking at what angle measure is sine square root of 2 over 2. So we know sine is opposite over hypotenuse. it's always easiest. It's easy to draw. Easiest to see when you draw a circle. So we know that the opposite is square root of 2 over 2 at the place on the unit circle that ends, or where the denominator is 4. Because when the denominator is 4 at any point in the unit circle, for radians, it could be here, 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 here. It gives us a 45, 90 triangle as a reference triangle, and that is what gives us square root of 2 over 2 as the opposite. And that angle measure, theta or whatever in radians, is pi over 4. Okay, slay. Cosine inverse negative square root of 2 over 2. So we can see here, the negative is in this quadrant here. So where cosine is adjacent over hypotenuse, so what angle measure would give you the adjacent measure of negative 1/2? It's going to be something that ends with a 3, or has a denominator of 3, so it's going to be up here. So you kind of just have to have a good understanding of your unit circle. Am I doing this right? No, hold on. It'll be here. This would give you the adjacent angle of square root of 2 over 2. And where is this angle? 3 pi over 4. I don't memorize the exact points of the unit circle. I just kind of draw the angle and then think about it. Like in this case, we broke this into 4, 1, 2, 3, 4, and it's 1/4 away from pi, which is here. So it's 3 pi over 4. Yeah, anyways, moving on. Sine inverse of negative square root of 3 over 2. So look at referring back to this. It's going to be down here. We need to find the angle where the opposite is square root of 3 over 2. So I don't know if this is very useful, but actually it is useful. But in my unit circle video, I was showing how okay, well, if it's like this, the bottom ends in 3, whatever the angle is. And if it's like this, the bottom ends in 6. The denominator is 6. And so with the ones where the denominator ends in 6, it will give you a opposite side of 1/2. And with the ones where it'll give you the opposite side of 1/2 and the adjacent side is square root of 3 over 2. And with the points on the unit circle in radians that end in 3, it's going to give you the opposite, the opposite of square root of 3 over 2 and the adjacent side of 1/2. So it's opposite of the ones where the denominator ends in 6. Right, so when I look at my problem and, okay, yeah, what am I saying? Yeah, so that's that. And so, but if I'm doing, so say like this problem, right? If I'm trying to find, keeping SOHCAHTOA in mind, if I'm trying to find one with the opposite side is square root of 3 over 2, I'm going to want to use a measure that ends in 3, because that would give me the opposite side of square root of 3 over 2. So all these end in 3, right? Yeah. basically how I think of it. And then if it's asking about square root of 2 over 2, that's easy. It's just the ones that end in 4. So when you think of it like that, it brings down your, it like eliminates the other points and brings down the possibilities. Anyway, it makes your options more clear. And then from there, from the 4 points, you just have to remember these. And that really brings it down. So, I don't know if that makes sense. But that's how I think of it. Okay, let's do another one. Cosine inverse square root of 3 over 2. So now I'm going to need one where the adjacent side is square root of 3 over 2, which, like I was talking about earlier, it's going to be one that ends in 6. And let's just draw a circle. It would be like over here, right? 6 is the skinny one, yeah? It would be over here. And that's in the domain of cosine. So we know that's the right answer. Now we just have to figure out the angle measure, which is 5 pi. Okay, let's do a few tan examples and then I'm going to go to sleep. So tan inverse negative square root of 3 over 3. You're going to want, so tan is opposite or adjacent. So you need to figure out what measures of sine and cosine would give you square root of 3 over 3, which we would need 1/2, right? 1/2 opposite or adjacent square root of 3 over 2. Because this would give us that. Yeah, it would. So knowing that, we need one where the opposite is 1/2 and the adjacent is that. So we need one where the adjacent is longer than the opposite. That would be here, and that would give us, it would give us negative pi over 6 because all students take calc. Yeah, so the same rule applies for when you find the answer. You just check whatever, if it's negative or positive, and just double check that it lies in this domain, which it does. Let's do another example of tan. So let's do tan inverse negative square root of 3. You're gonna want one where the opposite is square root of 3 over 2 and the adjacent is 1/2, and that will give you square root of 3. So what did I say? Opposite is square root of 3 over 2. So you want one where the opposite is longer than the adjacent. So when the adjacent side gives you 1/2, then the radian thing ends in 3. Yup. So that is how, what's this? So that's how you find inverse trig functions. Yeah. I think that's good. Okay. Good night, friends.